The next problems, now the problems based on differential equation. So we write down the first problem. Solve the differential equation. Solve the differential equation d by dt of y of t plus 2y of t is equal to x of t. For input x of t is equal to e raised to minus 2t u of t. Now assume 0 initial condition. So first we write down the given differential equation. So the differential equation is dy of t by dt plus 2y of t is equal to x of t. This is equation number 1. Now unilateral Laplace transform equation 1 can be expressed as, we write here, unilateral Laplace transform of equation 1 can be expressed as s into ys minus 0 plus 2y of s is equal to x of s. But initial condition are 0. We write here initial condition are 0. Therefore y of 0 dash is 0. Now the equation become s, therefore s into ys plus 2y of s x of s. So we can write this equation in the form of x of s. This is equation number 2. Now x of t is e raised to minus 3t u of t. Now we have standard Laplace transform pair. So what is this standard Laplace transform pair? So it is e raised to minus at. Its Laplace transform is 1 by s plus a. So we have to consider here standard Laplace transform pair. So e raised to minus at Laplace transform 1 by s. Therefore e raised to minus 3t u of t, it is its Laplace transform 1 by s plus 3. So we can write x of s is equal to Laplace of x of t is 1 by s plus 3. Now we put this value in equation number 2. Put this value in equation 2. So y of s into s plus 2, it is 1 by s plus 3. Therefore y of s, it is 1 by s plus 2 s plus 3. This is equation number 3. Now we have to use partial expansion form. So in partial expansion form we can write ys is a1 by s plus 2 plus a2 by s plus 3. This is equation number 4. Now next step is calculate values of a1 and a2. So first a1 is s plus 2 ys at s equal to minus 2. Therefore a1 is s plus 2 into 1 by s plus 2 s plus 3 at s is equal to minus 2. Now we substitute this minus 2 value in this equation and we get a1 as 1 by minus 2 plus 3, that is 1. Now next calculate a2. So it is s plus 3 into 1 by s plus 2 s plus 3 at s is equal to minus 3. So we get 1 by, we substitute this s value and we get it is minus 1. Now we write, we substitute values of a1 and a2 in equation number 4. So ys is 1 by s plus 2 minus 1 by s plus 3. This is equation number 5. Now we have standard Laplace transform pair. We have standard Laplace transform pair. So it is e raised to minus a of t u of t. Its Laplace transform is 1 by s plus a. That is Laplace inverse of 1 by s plus a. It is e raised to minus a t u of t. So Laplace inverse of 1 by s plus 2, it is e raised to minus 2 t u of t, and Laplace inverse of 1 by s plus 3 is e raised to minus 3 t u of t. Now we combine these two equations and we substitute these values in equation number 5. So y of t is e raised to minus 2 t u of t minus e raised to minus 3 t u of t. So this is our required solution. So this problem was asked in exam for 6 mark. Now next is next problem. The transfer function of LTI system is, now problems based on transfer function. So the transfer function of LTI system, that is linear time invariant system, is hs equal to 2s minus 1 divided by s square plus 3s plus 2. So determine impulse response. Determine impulse response. So what is given? hs is 2s minus 1 divided by s square plus 3s plus 2. So we can write 2s minus 1 divided by s square plus 3s plus 2 is equal to, it is s plus 2 into s plus 1. So we can write this equation as a by s plus 2 and plus b by s plus 1. Now here we directly write the values of a and b by using partial fraction. So by partial fraction expansion we get a as 5 and b as minus 3. So hs is equal to 5 by s plus 2, it is minus 3, minus 3 by s plus 1. So here we take inverse Laplace transform. Therefore h of t is 5 e raised to minus 2t minus 3 e raised to minus t into u of t. So we have standard Laplace transform pair for 1 by s plus a is equal to e raised to minus at into u of t. So we use this equation and we get this answer. Now next problem, third one. The relationship between input x of t the relationship between input x of t and output y of t of causal system is described by differential equation given below. Now use Laplace transform to determine transfer function plus phi dy of dy so this is given equation. Now here we assume zero initial condition. So the Laplace transform for the given differential equation we can write. So first we write assuming zero initial condition. Assuming zero initial condition. So the Laplace transform of given differential equation can be s square y of s plus 5s ys plus 6y of s is x of s plus s into x of s. Therefore y of s is s square plus 5s plus 6. It is x of s 1 plus s. Now we take the transfer function. So transfer function is hs is equal to y of s divided by x of s. So h of s is equal to, it is 1 plus s divided by s square plus 5s plus 6. So this is the required transfer function. And this problem was asked in exam for 8 marks. Very simple problem. Now next problem. In the system given below, x of t is equal to sin t u of t. In steady state find response. In steady state find response y of t. So it is 1 by s plus 1. It is y of t. It is x of t. So what is given? X of t is equal to sine of t u of t, and hs is 1 by s plus 1. So the system response is y of t is equal to xt convolution h of t, and ys is xs hs into. Now here x of s is 1 by s square plus 1, and h of s is 1 by s plus 1. So y of s is 1 by s square plus 1 s plus 1. It is 1 divided by s minus j Now we have to use partial fraction expansion form. So in partial fraction expansion form, we can write ys is a1 by s minus j plus a2 by s plus j plus a3 by s plus 1. Now we have to find the values of a1, a2 and a3. So if we calculate values of a1, a2 and a3, a1 is equal to here I directly write the final answer, that is 1 by 2 into j minus 1. Now a2 so here the final answer is 1 by minus 2 into j plus 1, and a3 so it is half. Now we substitute these three values in the above equation. So y of s is equal to by 2 into j minus 1 into 1 by s minus j plus, not plus actually, it is minus 1 by 2 into j plus 1 into 1 by s plus j plus half into 1 by s plus 1. So we take the inverse Laplace transform So y of t is equal to 1 by, it is e raised to jt u of t, e raised to minus jt u of t plus half e raised to minus t u of t. We just simplify this equation. So it is 1 by 2 into j plus 1. It's common. It is e raised to jt minus e raised to minus jt u of t plus half e raised to minus t u of t. Now y of t is minus half sine t u of t plus half e raised to minus t u of t. So this is required equation. And this problem was asked for 4 marks in exam. Now the next problem. A causal system having transfer function hs as 1 by s plus 4 is excited with x of t is equal to phi u of t. Find time at which its output reaches 90% of its steady state value. So first we write down the given equation. So what is given equation? It is hs is equal to 1 by s plus 4. Now for first order system, the rise time of system is given by tr is equal to 1 by s plus 4. tr is equal to s of infinity divided by h of 0, where s of infinity is limit t tends to infinity s of t. So limit t tends to infinity phi u of t phi u. But we have h of t Laplace inverse of h of s. So it is e raised to minus 4t u of t. Therefore h of 0 is e raised to 0 u of 0, it is 1, and tr is phi u by 1, that is phi u second. This problem was asked for 4 marks in the exam. Now the next problem. This problem is was also asked for 6 marks. Find transfer function of system governed by following differential equation. So d3y of t cube plus 8 Now this is given differential equation. Now we take the Laplace transform on both sides. Take Laplace transform of both sides. So it is s cube ys plus 8 is constant, s square ys plus 6s ys plus 11 y of s equal to e raised to minus 2s x of s. Now ys is common, taken outside the bracket. It is s cube plus 8s square plus 6x plus 11 equal to e raised to minus 2s x of s. So the transfer function means what? hs, which is equal to ys by x of s. So it is e raised to minus 2s divided by s cube plus s square plus 6s plus 11. In this way we can solve problem. 6 marks problem. Next problem. A stable system has input x of t and output y of t. Use Laplace transform to determine transfer function and impulse response h of t of system. So what is given? xt is e raised to minus 2t u of t, and y of t, it is minus 2 e raised to minus t u of t plus 2 e raised to minus 3t u of t. Now we take the Laplace transform of input and output, that is these two functions. Take Laplace transform of input and output. So xs is 1 by s plus 2 and y of s is minus 2 by s plus 1 plus 2 by s plus 3. Now transfer function is hs is equal to ys by x of s. So h of s is equal to minus 2 by s plus 1 plus 2 by s plus 3 divided by 1 by s plus 2. So h of s is minus 2 by s plus 1 plus 2 by s plus 3 into s plus 2. So hs is minus 2s minus 6 plus 2s plus 2 divided by s plus 1, s plus 3 and s plus 2. So we solve this equation and we get hs is equal to so it is minus 4s minus 8 s plus 1 s plus 3. Now this is transfer function of system. This is transfer function of system. Now to calculate the impulse response, we perform partial fraction expansion. So hs is equal to a1 by s plus 1 plus a2 by s plus 3. Now we have to calculate the values of a1 and a2 now. So a1 is equal to s plus 1 into minus 4s minus 8 divided by at s is equal to minus 1. So here I directly write the final answer, and a2 is and value of a2 is minus 2. So we substitute these two values in our equation. So h of s is minus 2 by s plus 1 minus 2 by s plus 3. Now we take inverse Laplace transform. Take inverse Laplace transform, we get ht is minus 2 e raised to minus t u of t minus 2 e raised to, and this is impulse response of the system. Now next problem. These all problems was asked in exam for 5 marks or 6 marks, 8 marks. Next is find transfer function of first one ideal differentiator, second ideal integrator, and third one ideal delay of t second. So first is ideal integrator, ideal differentiator. So at initial condition, now at initial condition it is 0, so y of t is d by dt of x of t. So ys is sx of s minus. According to definition of transfer function, so hs is equal to ys by xs, that is equal to s, this is 1. Now second is an ideal integrator. So at initial 0 to t x of tau d tau, so ys is 1 by s xs plus 1 by s y of z. Now according to definition of transfer function, hs is ys by xs, so it is 1 by s, this is equation number 2. Now next is third one, an ideal delay of t second. So initial condition, we write here initial conditions, and initial voltage in buffer are 0. So yt is x of t minus capital T, and ys is x of s e raised to minus st. Now according to definition of transfer function, hs is equal to ys divided by x of s e raised to minus st. This is equation number 3. So this problem was asked for 6 marks. Next problem, state relationship between Fourier transform and Laplace transform. Now Fourier transform of CT signal is special case of Laplace transform. So relationship can be given as xs is equal to Laplace of x of t. So integration minus infinity to infinity x of t e raised to minus st dt. Now where s is what? It is sigma plus j omega, which is complex variable. It is complex variable. That is x of sigma plus j omega, it is minus infinity to infinity x of t e raised to minus of sigma plus j omega t into dt. Therefore x of sigma plus j omega is minus infinity to infinity x of t e raised to minus sigma t e raised to minus j omega t dt. But we know the definition of, the definition of Fourier transform. The Fourier transform of x of t is minus infinity to infinity x of t e raised to minus j omega t dt. So x of sigma plus j omega, it is Fourier transform of x of t e raised to minus sigma t. That is, the Laplace transform of x of t is equal to the Fourier transform of Ct signal of x of t e raised to minus sigma t. So if s is equal to 0, then Laplace transform reduces to Fourier transform. That is, here Laplace transform of x of t is equal to the Fourier transform of Ct signal x of t e raised to minus sigma t. This problem was asked for 2 mark in university exam.